So what do we have here? We have A, which is a struct. We have a test struct that accepts A as a parameter, just like embeds it. And then we have some test code, right? It creates A on the stack, it takes a pointer, and then it assigns A to a pointer, right? So T takes A as a regular type, and we assign a pointer to A. And what Jai does is, Jai lets us out to dereference that. So under the hood, it literally does that, right? This happens under the hood implicitly. And what I want to do is I want to detect this behavior and maybe not entirely ban it, but at least report when this happens. So in case you debug maybe some like segmentation faults that are related to access and invalid memory location, you can see all of the pointer dereferences that you might not have intended to do. So that's our plan for today. And we need to do that, but we also want to exempt a valid dereferences. So we want to exempt explicit dereferences. So this should be detected and reported, and explicit dereference should be fine. Yeah, that's the goal. That is the goal. Yeah, welcome everyone. Welcome. I see people are coming in. Nah, YouTube suggested me your stream and I'm not following. How could you? Yeah, I mean, yeah, discoverability on YouTube is literally the worst for streams. And it makes sense, right? Because streams are very expensive for the platform. So they probably want to have it as a feature to compete with Twitch, but they definitely don't want to advertise it, right? Hey Jumpy, hello. Welcome to the stream. But yeah, you found me now, so welcome to YouTube. Yeah, so yeah, that's kind of the thing. Ilionte roasting me for me being a fan of automatic dereference got to a point where I was just thinking about it and I realized that, in this programming language, you don't actually have to choose between having automatic dereference and not having it, because you can literally just write a metaprogram that can detect it at compile time. And if you don't want any implicit dereferencing, you can just ban it on the user space. Isn't that crazy? I think it's kind of crazy. Right, let me just condense this down. And yeah, here's our handle type check. So how do you even start it? I guess we kind of go... So because automatic dereferences, they can literally happen anywhere, right? They probably can't happen in the procedure headers, if you think about it. They definitely can happen in default initializers here. You can definitely automatically dereference shit here. And you can absolutely do it in procedure bodies. So this is what we call like a non-imperative scope in Jai. And this is like an imperative scope. I guess we need to check all... I actually don't know how you get messages about default initializers. Do you get them as procedure bodies? Because, under the hood, Jai creates an initializer of procedure. So maybe that's what you get in the metacompile loop. So we'll have to see that. But for now, I guess we'll start with the simplest possible example is you get procedure body, you get a statement, and the statement looks like this, right? And we want to detect that. I like automatic dereferencing. I do it in my latest transpiler. It's so easy for the compiler to know, and it feels way more fluid always. Yes, that's why modern languages do that. Just because it's so convenient. Yeah. I mean, exactly like that, yeah. It's just very convenient not to have it. But you know, some people don't like it because it can definitely lead to some oversight when you dereference something you didn't mean to dereference to dereference. Like I did yesterday with my Vulkan code, where I screwed up. So yesterday I had a situation where I was manually writing struct definitions for Vulkan, and the struct that should be accepting this, I accidentally wrote it like that. Yeah, but the compiler let me have it because it would just automatically dereference a pointer. And this pointer should not be dereferenced because later it would the internal Vulkan driver would read it as a pointer. And so I would get crashes for reading from invalid location, right? And if Jai didn't have automatic dereferencing for structs, I would be instantly getting a compile error, right? Because for numbers, you can have it. So if you have a number which is S64, right? And you try to like have a number and then you try to do this, that n equals like pointer to b, you can't do that. Jai won't let you dereference this, right? You will be getting, wait, what? Yeah, this is not a tab. Yeah, you see mismatching level of indirection. So you can only automatically dereference structs like that. You can't dereference primitives. And so if it was also the case for structs, I would be catching that error, that mistake that I made way earlier. And instead of that, I spent 45 minutes doubting the X11 code because, you know, X11. So yeah, that's what we'll be exploring today in ways to optimize, not optimize, but automate it. And to start, I will be getting procedure bodies and iterate over all the statements in procedure bodies. That's what I will be getting. And to do that, we can go to compiler module, right? In compiler here, and we get a message type checked. Yeah, there you go. It has a message under the hood, and it has declarations, procedure headers, procedure bodies, structs, and some others. Here we have arrays, blah 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 blah, so that we don't get all of that if we don't want. Different things, even if they're not defined at top level. Okay, yeah. If you know for sure the data is bound to a name in a top level scope, you could take a policy of just looking at the declarations. Yeah, okay. Procedure bodies. So I want to iterate over procedure bodies for now. We didn't want to have a zillion arrays. Yeah. What's that? Oh, okay. This is for top level statements. Top level state. Probably don't want all. Anyway, so here we have a message type checked. So for message procedure bodies. But would the arrow operator really fix that, or could you just have easily mistyped, or am I I mean, in my case, the problem was that I literally wrote the type of the struct incorrectly, right? And so I was trying to assign a pointer to X11 display to struct that should accept a pointer. But since I mistyped the definition of a struct, I was assigning a pointer to display to a struct that just accepts the display. And so Jai would dereference that pointer. And if instead I got a compile error like, hey, you're trying to automatically dereference a pointer, or you're trying to pass a pointer to something that doesn't take a pointer, I would start questioning myself like, oh, why am I dereferencing the pointer here? And oh shit, that shouldn't be, this like shouldn't be a real struct in the first place. So yeah, I just messed up the struct definition. Let me fix it real quick. Right, so yeah. Yeah, procedure bodies, let's just PB. Let's just print stuff. So like print. Oh, I actually want to do import print vars. Print vars is a special module in Jai that's like just prints an actual stuff an actual like variable is very convenient. So you can just do pb that and dereference that chat. To use, okay, it's not a, wait, what? Ah, yeah. It's print vars. Cool. So what do you have here? And is not a member of test. Oh, yeah. So I deleted that. Okay, yeah. So we get procedure bodies. We get a lot of procedure bodies. I think Emacs is about to die. So let's... no, it's over. Okay. That's many lines. That's a lot of lines of code. So how did I iterate over it? Let me do build alt here. I'm doing that actually. So type checked procedure bodies, right? And I get body is an expression. And after that, I assert that the block is not null, and I actually get statements of the block. Makes sense. Let me just retype it so I keep it in my muscle memory. So again, we get body itself, which is expression. Expression. Then we get block is body.block. Hey Dunka, what's up? Hello. I think that's it. Of block statements. And you know what I also want to do? I want to kind of restrict it to my main for now. Yeah. I wonder. Yeah, maybe you made me think about it a little harder than I initially thought. And I realized that, you know, in this language, you don't actually have to choose if you want automatic dereferences or not. I mean, you don't have to be forced in one way of thinking. I mean, you can literally choose if you want automatic dereferences or not. In my case, I will start with just detecting them. And then we'll see if we could like just ban them or display them or whatever. Next, let me also get the procedure header for the block. Proc header is body.header, right? And if proc header name not equals to main, we will just like here continue. Easy clap. Let's do that. Okay, nice. And here print vars, and let's do statement. Okay, we have a few statements. We have a declaration. Let's open the main here on the side. It's ptr.js. So we have a declaration. Here's the declaration x. Then we have another declaration, which is this px pointer to x. Then we have even more declarations. So t is a declaration. Cool. Then we have a binary operator. So equals, right? Binary operator. Another binary operator, and then procedure call for print. Let me actually remove the print because I don't really need that. Let me also put the comment here. Right, okay, and we have a binary operator. I'm kind of actually... this is actually interesting that we don't get like an assignment or anything, just straight up binary operator. So it means that we need to recurse down into the binary operators to see if it's an equal sign. So do we not have a high level compiler? So do we not have like a high level thing for assignment? We have assignments. Oh, we have it for comma separated arguments, right? Yeah, so I guess we need to do this. You need to recurse into the operator type and see if it was an assignment operators aside from equals. Oh, operator type. So it's probably is equal, is not equal. So are those operators that are not just single character, and all other operators are just, you know, number by the character? If op equals to, yeah, so there's no like separate stuff for it. What do we have here? A binary operator. So binary operator, this is the code node, binary operator. Yeah, code binary operator. There you go. Right. So if statement dot kind equals to binary operator, then we do op equals to cast code node code binary operator and statement, and then let's print vars this motherfucker. Okay, binary operator allowed by context and some pointers. What do we have here? Operator type. This might be a member of enum operator type, or might be an ASCII value. Yeah, which is out of range of the declared enum values. So loose, that's pretty cool. Like loose is a thing on JI enums that lets you set a values that's, you know, don't really fit into the enum, which it is like a very niche use case, but sometimes they're useful. For example, in X11, like you have enum atoms that are kind of typed, but then atoms might be like whatever number. So, you know, the enum has to be loose. Niche use case, but I guess sometimes it's useful. We have also nodes, alignment expression. What the fuck is alignment expression? Declaration properties. Oh wait, this is the wrong one. Yeah. Flags. Left and right. Okay, we can have left and right. What are the flags? This is one like allow. Yeah, these are flags. Node flags. Expression is spread, no array bounds check, allowed by context. What does it mean, allowed by context? Statement is deferred, is parenthesized, no arithmetic created by desugaring. I think this is irrelevant to us. Yeah, I'm pretty sure it's irrelevant to us. So we will be looking into left, right, right, left, right, and operator type. Yeah, it's like left, right, and 61 is the character code for equals, I assume, right? How do we verify it? Man. Oh no, I'm in Python. I'm sorry. Holy shit. Look at this. 61, yeah. I didn't know that there's a manual on ASCII. Cool. Okay, so if op dot. Isn't it funny that we are using automatic dereferencing in the code that should detect automatic dereferences? Equals this, then print vars. Let's check the op.left dot star and op.right dot star. Let me actually do that so it prints on the side. Look at this. So left is, how is left a binary operator? Oh, binary operator like is as a star, right? So dot is a binary operator, and right one is a cast. So seems like cast will tell us if it's a reference or dereference, right? So let me just explore it further. If op.right kind equals cast, then our cast, I'll just like cast underscore equals to cast op.right to code cast, I guess, and print vars. Let's explore that. So we have a cast of a cast is implicit is pointer dereference. Huh. There you go. We found it. Right? So we have our main binary operator. Right? We have a left and right side. Right side of the binary operator is a cast. And the type of this cast is implicit and the pointer dereference, right? And so it means that we want to detect that. So this is what we want to detect. And in the other case, it's unary operator. In the second case, unary operator. Whatever it is, let me check what I wrote there. Here. Right, so here's an implicit cast with a dereference, and here is a unary operator. So explicit dereference is a unary operator. But I wonder why this is a binary operator, dot, but dot star is a unary operator. Oh, because this dot has a left side and a right side, right? So left side is a struct, right side is a struct, left side is a struct, and right side is a struct field, right? But this is unary operator because that's how it reads. So it's not like a star, it's star dot, which is an operator, right? Star dot star. Is there nothing like that? Dot and star. Yeah, there you go, dereference. Pointer, yeah, is a unary operator. Okay, you see, I was right. I just looked at the output of a metaprogram and I got a right intuition for it. Which I guess makes sense considering that I'm programming in this language for like two years already. You would expect someone to have an intuition for something that you're doing for 2 years. Even on a side, you know, I don't program Jai full time for 2 years. But still. And we also have it as a postfix operator. Oh, I think it is a postfix dereference in case if it has something after that, right? Just let me just verify it. If, for example, we do this and dot a, I don't know. I think it's just, yeah, it's not gonna type check. So we have a, and maybe a will also have a, which is like a int or something. Type mismatch type. Let me do like b int and b semicolon. Yeah, unary operator and binary. Yeah, it's like a binary operator, and I bet that it would be like a postfix, blah blah blah. You think so? But I got a unary operator here, even though I didn't use it like this. You see, I use it like that and it got detected as a unary operator. Anyway, the point being is that we got our fucking implicit is pointer dereference. If kind equal cast, and then what do we do? Code cast. Target, we don't care about the target. Expression, code flags, cast flags. Okay, if cast dot cast flags and dot is implicit, I think I can just do this, right? Is pointer dereference, like print dereference on, and here we should like print location. There was something like print. Wasn't there something for printing location? Code location. Source code location. Assertion handler. And where's on the code node? Location. Kind location. Okay. Yeah, literally just location. Oh, wait, what? It's not a code location, it's just literally location. Index of the starting line. C0 index of the starting character in bytes. Do we have a file name on message type checked? Message type checked has a message, and message has a word. Fuck. Do we have like a file or what? Oh, do I need to listen to message file? Case that file. Oh. Bruh. Message file. mf equals to cast message file message. And what do I want to print? Let's just print it. We have a fully path file name. And I guess that's it. MF, like motherfucker. Fully path file name. And I guess we can also have it as a string in case it's a build string or something. That's okay. Let's see. Where do I miss the semicolon? Oh yeah, it's. Wait, what? Incorrect number of arguments. All right, yeah. Just whatever. Okay, yeah. So we have file. Oh. So you don't have them in turn, right? You have a bunch of files, and then you get procedure bodies. Then you get more files. Source code location has a file, no. Code location has, but that's not code, right? That is not a code, unfortunately. Or I guess rather code node doesn't have it. And seems like message file doesn't give us those in turn. What else was there? There's like message import. Message phase. All source code parse, type checked all we can, target code build, pre-write executable, blah, blah, blah. But code node has like a regular location. Oh shit. I am I look right at it and I don't see it. It's literally here, message file, and it has a file name. Okay. Bro, I mean, I hope someone in the chat caught it. File equals, what do we have? Cast dot and closing load. Right, and we need to print file dot fully path file name. Let's see what it's gonna be. Found implicit dereference. Yeah. Dereferenced in, and then do like line and a column. So file path name, and then cast dot location dot L0 and cast dot location dot C0. And yeah, found implicit reference in blah 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 1411 here. Whoa, what? 1411. Yeah, here literally points us at the right where we want it to be. Yeah, this should be detected and reported, and we detected and reported it. Nice, that's a very easy W. It took only like 40 minutes and I almost was productive almost throughout. So what other cases we have for implicit dereferences? So I need to use code visit because let me like not print that. So I only have let me just remove all the print vars. Yeah, we do that. And found implicit dereference. Yeah, here, coolio. Yeah, procedure arguments. And maybe default initializers for structs, right? The ones that are in declarative scope. But maybe they're reported through procedure bodies of, initializer of. So we'll see that. So we have like a test procedure, which for example might take A of type A, or maybe like test. Right, and let's say if you want to like call test with pointer to something, right, like px, or no, like pt equals to pointer to t, right, and we just call pt here and we compile. So this is gonna be implicitly dereferenced into this, like, right, like t is, can I, thank you, here t is 0 0. Why is it 0? It's px. Ah, yeah, because it's like literally all. Yeah, let me do something like, so I got the pointer. Px dot a equals 5. This is also an automatic dereference, right? Because explicit one would be this. So this should be detected. So dereference, but on the left side, also should be detected. This should be detected. This should be detected. This should be fine. This should be detected. Do I detect it on the call side or on the receiving end? No, of course on the call side. What am I talking about? Yeah, feeling productive. This is also a binary operator, I'm pretty sure. Right, and let's print left side and the right side. Literal binary operator cast found. Oh, binary operator and literal. You have binary operator and literal. Oh, wait a second. So this one is binary operator. So I need to visit that as well. Ooh. Ooh. Right side can be arbitrary nested, but I think... So, like, this can be detected, right? But I'm pretty sure if I have, like, an arbitrary nested kind of implicit dereference, then the top level will still be a cast, right? No matter how complicated this part of the equation is, if the resulting type is a pointer and it is dereferenced, then the kind of overall type here will be implicit cast. So this should be fine no matter how hard it is. This, on the other hand, though, well, can I actually do something like, maybe like, let's do A equals like 5, right? Pointer to A equals pointer to A. Can I do PA equals 5? Can I do this? Okay, that's actually impossible, right? So it doesn't really work on primitives. So it doesn't let me assign a primitive literally to a pointer. So the automatic dereferencing isn't always working. So this will require me to dereference explicitly. So it doesn't let you go like all the way. I guess it only looks into like structs or whatnot. Yeah, what if I do strings instead? Right, what if it's like hi, and here's the pointer, and I do this by also. Oh. Yeah, so it doesn't let me do that. But will it let me do that on the data? Hey Vivian, I mean, yeah, all modern languages, I think all modern languages have automatic dereferencing, right? Does actually Zig have automatic dereferencing? I mean, Zig is quite anal usually. Automatic dereference is such a modern meta that I wouldn't be surprised if it has it. Let me check real quick. Zig dereferencing. I mean, yeah, there is a pointer dereference, but... okay, it's optional. Okay. Fields can be accessed directly without explicitly dereferencing the pointer. Okay, fields can be accessed directly, but can they be assigned to directly? That's a completely different point. Anyway, I'm not gonna like go on the documentation bender. I was just curious. So this doesn't work, right? It literally doesn't let you do that, but will it let me do that on the data pointer? So for example, we have a pointer to the string, and I can do this, like 5. And this is just fine, right? It lets me do that. But it's the same as here. And I guess it will let me do the same with the data pointer too. So, right, data actually accepts the pointer, so it doesn't make sense. Yeah, I guess it's, I guess it's the same. So this should be detected. Let's work on that one. In this case, what do we have here on the left? We have a binary operator. 2, again, binary operator. So here we're checking right one. Let's do if op.left.kind equals to binary operator. Then let me, again, print recursing into left. So we have binary operator, we have right as literal recursing into left. Left one is another binary operator. And right is literal. What? Oh, I'm an idiot. We need to left op equals to cast. Yeah. I need to code binary operator and op.left. Yeah. And now I need to access these on left op. Yeah, like that. So recursing into left. We have left op left is identifier. And right is also an identifier. So there's like 2 identifiers. Oh shit. So both of them are identifiers. And how do I detect that it's like a dereference or something? It doesn't say cast here. Am I even looking on the correct one? PTR. Yeah, this we don't do. We do the binary operator. Here's the literal. Yeah, operator, literal, and 17, line 17, right? This is line 17. Yeah, it is a line 17. Okay. So we're looking at the right thing, and left one of the left side is identifier, and the right is identifier. So left is gonna be left up dot left, and right is gonna be left up dot right. I think I'm gonna be super confused about all these lefts, rights at some point. And if left dot kind equals to ident, let's do ident left equals to cast to code ident and left, and let's print varset ident left. What is it gonna be? Recursing to left ident. Oh, I need to dereference it. Woo. Recursing to left, ident left is identifier px. So this is the name of one identifier. Wait, what? Oh yeah, correct. It is a px. Yeah, you're right. And right. Oh shit. Is this it? Oh wait, no. When we print in too much, I get confused in the print. But yeah, so we have left identifier is px, which means that the right one will just be called a. So this doesn't give me anything. Oh wait, I need to get the type of the operator here. So if left is a binary operator, I need to print that. So let me print varset, and it's gonna be left up that. Yeah, I want to check its type. So we're recursing. Left up is a code binary operator of 46. I mean 46 is a dot, right? So we'll do the cheat code, and code 46 is a dot. So yeah, there you go. It's an operator dot. We can actually check if it's a dot, right? And if left kind ident, if right that kind equals ident, we do the same. So far I'm writing like a really explicit code, but when we are kind of done with exploring, we can actually compress it with code visit. Ooh, and write some kind of a generic, generic traversal, where we just do this thing in a more generic way, so we don't like check for all of that. Or maybe the checking logic will be preserved, we'll just recurse. We'll see how it goes. Right ident recursing, left up, ident left, ident right. Px what? Oh, it's right, should be right. Ident right is a. Oh, look at this! Code identifier is right hand side of dot dereference. Fuck yeah. So we have left, we have right is RHS of dot dereference. Yeah, enforce house rules. That's what we're doing. We're not necessarily enforcing house rules, but we want to at least know what's going on. This keyboard has forsaken me. Yeah. So if I get dots, I need literally to recurse into dots. Is RHS of dot dereference. Compiler is RHS here. So on identifier we have this. What do we other have? We have defines polymorph variable of dot of an identifier is RHS is right hand side of dot dereference. Resolves shallowly, generated by operator overload, do not resolve due to parser. Can resolve to rec, has scope modifier. Scope modifier is like this. Right, this is a scope modifier. Yeah, so we need that. I wonder if it's used anywhere in the standard distribution. No, it's literally not used anywhere in the in the language distribution itself. I wonder if, you know, Thekla game, the Sokoban game uses it. So yeah, we need to check that. I guess if we get a dot, so we have stuff. If on the left we have a dot, we need to gradually recurse into it until we find this right-hand side of dot dereference. And I also wonder if you get this identifier like right-hand side on dot dereference, if you dereference explicitly. We will need to add that use case, right? So we get right hand ident right, and if ident right dot flags and is RHS of dot dereference, then we also need to print that file is equals to ident right dot enclosing load and file and cn equals ident right, and let's do that. cn is like code node, and let's do the same here. It's just so when I extract it, it's easier to me. Boom. Recursing to left, found implicit dereference on line 17 and found implicit dereference on line 20. Oh, we actually checked twice. Yeah, we check. Oh, wow. So why do you print line 20 twice though? Op left, op right, recursing to left, left op, indent left, found implicit dereference. Bam. Oh, shit. So does it mean that, right, so where is our line 17? Here we found implicit dereference on the line 17. Then we get the second one, binary operator, recursing into left, identifier left is code ident, and identifier right is A, is RHS of dot dereference too. Oh, so we don't even have to check for the cast. We don't even have to check for the cast. So these two are literally the same case. We don't even have to check if this is like a... But why? Wait. Why would this be a right-hand side of dot dereference? T is not even a pointer. Is RHS of dot dereference. Why would this one be RHS of dot dereference? Wait, am I missing something? Let me rename it slightly. A int, like test A, test B. Let me just slightly rename them. So px is pointer to x, like A is A. PA is pointer to A, then we do PA int equals 5. Then we do T is test, T dot test A equals pointer to A. And then T dot test A equals pointer to A dot dereference, and T dot test B equals to pointer to A that dereference that A, and pointer to T, and this should be detected. This we don't do yet. Let's compile, and A that struct A is not a member of A. What? Ah, this is A int. Cool. So it's just like easier to see what's going on. So here, test A. Yeah, it says that test A is RHS of dot dereference. That's like really weird. Let's go back here. Again, we see op left, right, unary operator. Left is a binary operator, recursing into left. Yeah, left is T, right is test A, and also RHS of dot dereference. So you see, it thinks that 22 is a dereference, which is not. Is right hand side of dot dereference. Oh shit. So maybe is RHS of dot dereference just generally means that, okay, this is the right hand side of a dot operator. So like, okay, this is a field of a struct. Maybe it doesn't literally mean dereference. It's just like, okay, this is dot field on the struct. Like is RHS of dot dereference doesn't literally mean that it's a dereference of, that this is a dereference. Because in this case, where is it, 22? Yeah. In this case, test A is not a dereference. Like it just says that, okay, this, like if you're a dot, if you're a dot after a struct, then it is a dereference. Either it's just, you know, like a name that's not very descriptive, or it's like a bug that it thinks that everything is a dereference. So this is kind of, we need to verify that. So how do we distinguish a regular dot access from pointer dot access? Let me think. Before I do, is there any questions about what we're doing? Serious on topic questions. Maybe if we recurse it to code identifier, we can see if it's a pointer dereference. Compiler code ident. We have a resolved declaration. So let's do dot declaration dot start like this. Result declaration is a call declaration. Type instantiation, expression, alignment. Have a call declaration. Type inst. This is a. So this is a type. Oh, can we? Can we? Type inst is null on it, but we have an expression. So we have B, and B is just literally a code node. It has a bunch of flags. What are flags? Is constant, blah blah blah, scope is global, has code modifier, alignment expression, nodes, program export name. It doesn't have flags, doesn't have anything, so it only has expression. It also has entry. What the fuck is entry? Oh, code scope entry. Yeah. So this is kind of useless, code scope entry. I mean, for us. Ooh, let's read its expression. Just like keep dereferencing until we do something. That expression, unary operator. Unary operator. Interesting. I wonder if this unary operator is a dereference. Expression is a code node, right? So unary, code unary operator. It has what? Operator type and sub-expression. So if it is an operator type, I wonder what it would be. So let's do that. Exper is this, right? Expression. Now if exper, so if it's not null, we will just print that motherfucker. Now if exper that kind equals to unary operator, smooth operator, okay, UO equals to cast to code unary operator exper, and then let's print vars, that motherfucker. What does it give us? UO.star unary operator of 42. What is 42? 42. Oh shit, it's a star. Look at that. Isn't it poggers? It's literally a star. Wait a second. Does it mean that we actually can dereference it? So we have left operator, which is a dot. On the left side of it, we have an identifier, right? Let me ident left. Let me just print. Let's do this like ident left is ident left dot name. Ident left is PA, and then unary operator on the expression is a fucking dot, right? And if we go here, then PA, you see, no, not a dot, a star. You see, PA actually doesn't have any fucking stars. Do we have any other unary operators there? We have unary operator on the right. Ident left T. Okay, ident left T. Yeah, so this is actually incorrect. We can't claim. We literally cannot claim if the right side is RHS of dot dereference that it is an actual dereference. I think this name just signifies that we are accessing a field of a struct. So let's comment that path out so it doesn't confuse us. And so PA star, right? So it's like kind of PA star, a int, yep. And then binary and literal. So this is that. Then we need this. So wait, no, not this. We have OP left, OP right cast. Yeah, this is our actual dereference that we detect through the cast. We recurse left. There is no like unary. Yeah, there's nothing unary about it, right? Identifier left is T. Yeah, and it is an identifier, but we don't go into it because it probably doesn't have an expression, right? If expression, else, let's do that. Print no expression on ident left that name. On left ident. No expression on left identity, right? But the right side is where is it? Yeah, but the ident right is a cast that we detect correctly as a dereference. And the next one is another dot T. Let me also print the right one. Ident right, we do this. Ident right is ident right that name. So it's just like less confusion. Maybe actually let me somehow, like, I don't know, instead of printing a statement, I want to just, you know, break those apart. Something like that. Oh fuck. Empty statements. Let me put it here. Yeah. So this is one. This is the second one. This is the third one and fourth one. That's much easier. Much easier. So the second one is op left. So left is T, right test A. T dot test A. And if we open our file, oh, PTR. If we open that file, yeah, t.test A. Yeah, t.test A, and the right one is a cast. Cool. Yeah, we recursed into left, and we did not detect that it's anything like suspicious. Yeah, it's not like a, and it doesn't have any expression. Yeah, so I guess that's where it holds a dereference. It holds it on an expression, because here, in the first case here, like pa.aint, yeah, we have pa.aint. Between those, there's a unary operator, which is 42, and 42 is a star. So if we open man ASCII, can I search like quote star quote? No, I can search, I can't, oh yeah, here it is, star, yeah, 42 is a star. So that's how we detect a dereference. Let's look at this one. Oh wait. Well, first let's look at this one. So pa.star that a int equals 6. So this should not be detected, right? And if I launch it, the first one has a unary operator, and the second one has a... Oh shit. Left op is binary operator. Look at that. It is a binary operator. So this is a binary operator, and it doesn't get detected as a... yeah, it doesn't detect it as a unary. It's a binary star. That's cool. Yeah, so this doesn't have, this is an implicit, this is an explicit. I just wanted to check if they are any different in the messages, and they are. So the explicit one, it has a binary operator. Here. Wait, it's a dot. Right indent is a int here. And indent left, there is no identifier left. Yeah, okay, there is no identifier left because the left one is literally another dot, right? So because left one is this one, is a dot, but both of them are dots. So have left binary, right literal, same left binary, right literal. We recurse it into left, and we found in a dot here. We print an ident left, and then we find in a unary operator. Here's 1, 2, 3. Oh, but the left. No, left is also binary operator. But we're just not finding it. So it's the same kind of, here's a dot and here's a dot. But here we're not recursing. Wait, why are we not recursing? Yeah, left is recursing into left. Here we go. Left up, left right. If it's because it is not an identifier, because the left side is a star, right? If an ident, let's do else. Left is not dent, and left not ident is a unary. Oh fuck, it is a unary operator. So we will be having a unary operator that is not an identifier, right? So look at the difference. The difference is that in the case of an implicit dereference, we have right hand side and left hand side of a dot. Both of them are identifiers. And we get unary star only when we look up an expression on the identifier. So we go identifier.expression, and expression has a unary operator. Okay? And in this case, we look at left side and the right side is an identifier, so the same as here, but the left side is not an identifier. Left side is a unary operator, like right away. Yeah, it's a unary operator. So file, location, and look at the code of a unary operator. What the fuck is this? It's literally different. Right? Oh no, because it's a code node. Let me cast it so that I can see what exactly it does. So else else if left.kind equals unary operator. Let me do this. UO right equals to, where do we cast it? Like here. Right, left is not an ident. UO left. How do we do? I can do this. Left. I can just do this again and cast it. Wait, what? Oh, it's left equals. Oh, I can't reuse left, or can I? I don't think it. Yeah, because I'm using the thing inside of its own declaration, right? So let me just do this. So we get left is not an identifier, left is a unary operator of the code 169. So it's not just a star. 169 is actually something completely different. It's probably dot star. Where do we have it in the compiler? 169. Yeah, postfix dot star operator. Cool. So postfix dot star is an explicit dereference, but regular unary star is an implicit. Like this. Yeah, 42. Like this kind of makes sense. But it's also, you know, it would be more kind of safe just for me if this information was a bit more structured. Because now I have to look, like, this is an explicit one, right? This is an explicitly typed out unary.star. If we go here, ptr.jai, yeah, it detects this as a unary operator. Like, this is what it shows me on the left. Right, so whatever is on the left was explicitly dereferenced. So this is fine. And I mean, technically we need to, you know, go further because, okay, this was explicitly dereferenced, but what if something previously was implicitly dereferenced? Because this can be, you know, arbitrary kind of nested, right? And one of these might be dereferenced implicitly. So technically we need to go as further left as we want before we hit like the first one, right? So this is where you would use like code visit and whatnot. But for the simplicity's sake, for now, the way we tell one from the other is by looking at either explicit.star or on implicit star that is here. Oh, or sorry, that is here. Yeah. Which is kind of sketchy because since instead of telling that, yeah, this is a dereference, it just tells me there is like a unary operator of a star. It kind of tells me that, you know, what if this is like just an implementation detail that's gonna be changed. So yeah, I think I'm like, can I email John and ask them if, you know, he maybe can, instead of doing this, just say that like left side is an implicit dereference or something. But for now, let's go with the flow. And where's our build metaprogram? If ident, if left side is unary operator, right? And if UO dot unary operator, was it called? Operator type, yeah. Operator type equals star. Regular singular star means implicit dereference. In case of an explicit dereference, we would be getting operator type 169 unary dot star. Right. If this, then we actually, I guess, report that motherfucker. What did we report here? Cast. And in this case, we report the part that is unary operator. Yeah, so I guess we do like UO s32 type given string. Oh yeah, you're right, because it's a char. Okay, so found implicit import, line 15, 11. Okay, let's check it out. PTR 15, 11. Wait, what? The fuck? Is this the wrong one? Oh, I was seeing this star. So okay, it was explicit. I completely missed the lines. I should have looked at the lines. Fuck me. This line is 17. Damn. Okay, so this. Yeah. Okay. So this is like all wrong. This is a unary operator that is this star. But I started getting it because it is a binary operator. Okay. Yeah. Fuck. So what are we getting here? Why does it report? So it's correct, like a int, right? Indent right. But a int is here. 17. Oh shit. Look at this. So it, yeah. So this is not good. It gives the information, but it's not good. Look at this. I was right. So we get the operator, which is on line 17. This is the line. This is a column, right? So we get those on the line 17. But when we recurse, we get the unary operator dot, which detects itself on line 15, right? So this is what it shows me. You get an unary operator on this line that refers to this star. So it somehow like attaches a dereference like here. That's not good, man. That's like not good at all. Like it gives me the info, but it's kind of like backwards. So yeah, we need to add something here, which means I will have to figure out a way to like explain the issue nicely, right? Because like John wouldn't have like all the context we have here, and you won't make him watch 2-hour-long stream. Anyway, yeah, we'll figure something out. So instead of reporting line 15, we need to report it on the... I mean, I guess we can report it on the right side. Right, so... like PA is the one that's getting implicitly dereferenced. So we do identifier. Yeah, identifier is getting implicitly dereferenced. Right? Yeah. That's what we report. Left, it's left ident. It's ident left. Yeah, so ident left. Oh. Right? Yeah, ident left. And now it's going to be reported correctly. Yeah, we have a implicit dereference here. 17, line 17, 5. Yeah, okay, so yeah. This is correct. This is dereferenced implicitly. Nice. And the second one should still work, right? 21? Is it line 21? Yeah, line 21, column 16. Yeah, okay, this one gets... Right, okay. This is all working now, which is beautiful. Next case that we should detect is calling the function with a parameter that automatically dereference. I'm not gonna lie, like, metaprogramming kind of melts my brain a little bit. I already feel cooked. Yeah, so we find our dereferences. which is a binary operator. And I need to do the inspect the procedure calls as well. Else if kind equals your call, right? Let's stop printing all of these vars. Right, let's not print that. Procedure call, let's print vars of PC equals to cast to code procedure call statement. PC that we do format struct. Yeah, there you go. Wait, did I not? Right, I need to do one true. Cool. Procedure call. Let's inspect that. It's been a while. Code procedure call. So we have the code typed by the user. Okay. The expression after overload resolution and polymorphism resolution. Oh, I can imagine stuff. So what if there is a polymorphic procedure, one of them receives a pointer and another one receives not pointer? I guess the compiler would just complain then that more than one, it will either complain that more than one resolved polymorphs, can be called. So it's ambiguous, or it will just take whatever is not like implicit. So I will need to check either this one or that one. So args unsorted equals to PC dot argument unsorted, and args equals to PC arguments sorted. I'll just print both of them. And slide like for args unsorted. We're gonna print it that star, and for args sorted, I'm gonna also print it that star, right? And we're gonna do fucking jump scare every time. Hey Philippe, hello. I need to make this alert slightly quieter. Welcome raiders. Hello. I hope your stream went well. This is actually kind of questionable thing to do, because in Jai, when you pass structs, they are passed maybe by referenced anyway. So maybe what I'm doing here is kind of pointless, right? Because it's not like in C, your struct doesn't get dereferenced here. Like technically what you're getting is like a reference to the struct. But I want to see how the code layout looks like in the metaprogram. And ideally, I want to support like chains of an arbitrary depth, right? So if it's like A.B.C.D, right? And this one was a pointer that got automatically dereferenced, I want to detect and report that. I don't do it now. For now, I write it in a super manual way, manually recursing, but after I do all the manual work and, have a good understanding of the process in my head, I will condense it down with using code visit, and we'll just traverse the binary operators with code visitor, with the code visit module. Yeah, okay. So we have a code argument with an expression, and we have unsorted arguments with it's just type and location. Oh, it is a cast. Oh, so we have a cast. That's interesting. So instead of just doing that, we can instead do it that expression. that dereferenced. Boom. Right, so we have an identifier. And here we have a cast. What is this identifier doing? Code ident. That expression. And ident. That star. Let's see what's that. Can resolve to reg. PT. Can resolve to reg. I guess this means can resolve to register. Probably because the struct is small or something. So maybe I need to look into args sorted instead, because those are code node instead of arguments. What is a resolve declaration? Declaration type, we have an expression. This is scary. That expression. Yeah, Unary operator. Okay. This is a Unary operator, and I bet this Unary operator will be a star. That will refer to line 15. Let's actually verify that. Let's actually verify it. Hey, code dog. Hello. So UO cast to code Unary operator exper and UO that star. Yes, it is a dot, but it actually doesn't refer to a. It refers to line 26. 26 is to this one. Yeah. So this behavior is consistent. So the way Jai reports implicit dereference on the left-hand side of something, it just refers it to a dot on whatever previous line it happened. So for example, here, right, we have pa.aint equals 5. Pa here gets implicitly dereferenced because it is a pointer. And the way we know that it is an implicit dereference is because Jai gives us Unary star that it actually takes from here. Because this expression is on the line 27, right? But the Unary dot that we get in the argument is from the line 26, so this one, right? And if I move it upwards, like for example, where is PT? Where do we get PT? Like here, right? Yeah, pointer to T. And now you see this Unary operator is on the line 21. This is the one. So it gives us implicit dereference with a star that's literally referring to this star. So in this kind of implicit way, Jai tells us where exactly does this pointer come from, which in my case is kind of weird, right? It gives you all the information you want to know. It tells you that this is a pointer that was gotten like here, that you got here, but the way it tells you that is a bit weird. if you ask me, because you kind of have to jump through hoops to see that. So we kind of have two different ways to get a dereference here, to get the pointer here. We see in the ordered arguments, we can go back through the chain of identifiers and find this Unary operator. So 42 is its ASCII code. ASCII code is a star. 42 is a star in ASCII. Or we can go through the unordered list of code nodes, and this is a cast. And I'm pretty sure if I get the actual code node, it will tell me that it isn't an implicit dereference. Let's verify that, right? In the arg sorted, we cast this cast to a cast. Code cast. I think that's what it is. It And then we do cast.dereference. Yeah, you see it is implicit and pointer dereference. And if we if we go to our procedure and we change this to a pointer, then we don't get those anymore, right? I mean, we still get Unary star here, but the cast is not implicit anymore. Now it's like no bounds check, truncate, force, very force. Hast postfix syntax, right? So now this is a completely different cast. Actually, I wonder why is this a cast at all? Oh, because it's not a cast anymore, right? So this is not a cast anymore. Now it's just an identifier, right? Vars it. Yeah, because it's not a cast. That star. You see, now it's just an identifier. So this cast is now invalid. It just happens to work because apparently code cast and code identifier have like a similar memory layout. Yeah. So I guess we check for casts because it's probably easier than do this than doing that. Yeah, this unary operator that we're getting from completely like different line is kind of, yeah, I don't really like it that much. Yeah, let's work with the cast instead. So we go through arguments sorted, and then if it.kind equals that cast, then we cast the thing to cast. You got jump scared me again. Oh, hello, Zig gang. Welcome, people. Loris, thanks a lot for the raid. Appreciate it. Welcome. I hope your stream went well. Welcome, people. You can type !today in the chat, and you will see what I'm working on. Today, I'm detecting automatic dereferencing in a metaprogram. And Jai as a language lets you automatically dereference stuff in sort of like a ergonomic way, right? So if you have a struct that, for example, accepts another struct and you initialize it, right? And you like initialize the first struct, you get a pointer to the struct through the star. You can then get stuff from the pointer and just casually assign to it. And under the hood, Jai will do this. It will dereference the pointer and let you do that because, you know, it kind of understands what you want. So that's what's happening under the hood. But sometimes maybe you're like debugging some like gnarly segfault or like access violation, whatever, like on Windows. And maybe you want to see where are all your pointer dereference are. And looking at the code and seeing implicit ones are kind of hard. And so what we can do is we can write like a metaprogram, like Jai has crazy ass metaprogramming stuff. And if I run this metaprogram, it goes through all the abstract syntax tree of my program, and it is able to, you know, detect those, right? Found implicit dereference on this file in this line and column. So 17.5 is here, line 17.5. So yeah, it points us to the identifier that is getting implicitly dereferenced. And then like another case too, right? Line 22.16 and 22.16 is gotta be here. No, it's like here. Yeah. So it knows that t.test accepts a struct, but I'm assigning a pointer here. So under the hood, Jai does this. And we are detecting that it gets implicitly dereferenced, right? And we are reporting that. So that's what I'm working on today. I'm working on a metaprogram that detects these automatic dereferences. And now, before I got rated, I was working on the detecting when you pass a pointer to a procedure that accepts not a pointer. So it gets automatically dereferenced here, right? So I can detect these cases as well. Maybe your Vulkan app crashes inside the video driver because you accidentally put a struct instead of a pointer to a struct inside the other struct. but that would be would never happen. Yeah, nobody would ever waste 45 minutes of time to, you know, because you implicitly dereferenced something that shouldn't be a pointer. Yeah, that should be a pointer instead. Yeah, that would never happen to anyone. Never, never, never. Yeah, it definitely didn't happen to me yesterday. Yeah, absolutely, absolutely. But yeah, again, like, thanks a lot for the rate, and yeah, people, let me know if you have any questions. But just to point out, Jai only lets you automatically dereference struct fields, so you can't do shit like you know, have an integer, right? Then get a pointer to an integer, and then do stuff like px equal like 8, right? You can't do that. It doesn't let you do this with primitives. It will literally say, wait, it's like equal. It will literally say you mismatching levels of indirection, right? So it doesn't let you do that with primitives. Only with, like, how do you say it? Like complex types, right? So I was inside of a procedure call, and I was detecting the cast. Yeah, we get a cast, and we need to check cast flags, right? So if cast flags are one of the is implicit and is pointer dereference, right? Then we literally report it the same way as we did here. So far, I'm doing it very manually, very kind of hard-coded way, just so I understand the process. Found implicit dereference on line 28. Let's go. Let's check if that's actually a line 28. It is a line 28, and the column is 10. Yeah. Literally, this shit gets implicitly dereferenced when you pass it. And this is very cool because I don't even need to inspect the procedure header. So I was afraid that this is not going to be enough. I would have to like go and check the procedure header and see if it, you know, accepts a pointer or not. But yeah, I guess since in order for this procedure body to be type checked, this needs to get type checked first. I am getting all the information I need by this point. And I wonder if I can do something like test that accepts t pointer to test. So it becomes polymorphic. Will it prefer this one or this one? I assume since this polymorph is more specific, it just picks one. It should just pick it. Yeah, you see, we didn't detect it, and not t. T is, yeah, we can like dereferenced. Wait. T and t deref is t dot. Yeah, let's do that. Cool. So it just picks the correct polymorph, so I don't need to do anything here. But yeah, this just magically works. That's pretty cool. Right? Let's just do test 2. This should be fine. Yeah, found implicit dereference. Hey, Sloren, thank you. We're kind of taking W's. So, and now what I can do is I can try to compress the code path because now it's deeply nested. I can use code visit to like traverse into the binary dots and just go arbitrary left or arbitrary right until I find all of the implicit dereferences. Right, and what I can do about them is instead of reporting them in place, I would just accumulate them into array to report them when we type checked all we can. Yeah, because what can happen is that somebody can inject shit into the program, and we need to keep collecting those. So yeah, so we just report those at the very end. I think. Does it only do your own code, or if you use, you will get swamped? Yeah, that's a very good question. For now, it only does my code because I hard coded it in my metaprogram, right? So here at the very start, I literally said if procedure header name is not main, continue. But you can kind of easily make it configurable, right? You can, for example, maybe have it, right? So it's gonna be like like handle type checked, whatever, that you can like plug into your own message loop, and you can, apart from passing messages, you can just like, oh, check like, I don't know, check only my modules or something like that. Or like check only stuff in this file, right? You can give it a file, maybe you can give it a module or whatever. YOLO. I mean, it's not very robust right now, but we can definitely remove it, right? And let me remove this as well. YOLO. That's what we are able to find right now. We can't find that many because for now we only look at the top level statements, right? We don't recurse into the statements, right? And that is only basic. Yeah, that's only my program uses. But I mean, let's check it out. So we have runtime support, line 56, right? Runtime line 56. S.count equals starting cursor minus cursor. S is string, starting cursor is cursor. What is cursor? Is starting cursor. So it's this S32 buff count. Why would it be a dereference? That doesn't look a dereference that doesn't look like a dereference to me. 5615. It thinks that starting cursor is dereferenced. I don't think it is. And since it's on the right side, I think it thinks that it's a cast, and buffer is also, it's like right here in place. Why would it be a cast? I don't know. This is probably, so this is maybe something, I mean, most likely it's something correct, but because I don't see an issue. Let's debug it. Let's just check. Let's just like kind of go over it. If proc header name not equals this, continue. Right? Okay. We detect found implicit dereference, and so this is the case where we binary operator and the right side. So we have a binary operator. We get the binary statement. We do this. We get implicit dereference in, let's just do this, in cast. Is it cast? Yeah, it thinks that it is a cast. That's wild. Rename in hell. I mean, be thankful. You have a static strongly typed language that lets you do that. Imagine if it was like Python or JavaScript. You would be super fucked now. Cast.star and format struct. True. Okay, it is implicit. Oh, because I fucked this up. How do I do only both? Right, it is implicit cast, but how do I, is it not correct way to check it? Oh, it checks like either of these, right? How do I check for both? Ah, so that's kind of, so you say this, right? Yeah. So this is what you're saying. So like if I put a parenthesis, it's gonna be this. Okay, and now if I run, probably a lot of them will not be an issue anymore. No, I mean still a lot, right? We have implicit casts. Let's check implicit casts in a default alligator. Default alligator. default allocator module 1822 GG. Oh shit, this is a mem set. So memory heaps is implicitly dereferenced here. Oh, it's right, you see? Memory heaps is a pointer. Like it is an array of pointers. So memory heaps is an array of pointers. Why not? I mean, memory heaps is an array of pointers. Ah. I mean, data is a pointer, yeah. But it thinks that memory heaps got dereferenced. Hey, Hover. Hello, hello, hello. No. Bug from yesterday is fixed. It was not really a bug. It was me, an idiot. Yeah, so it is a struct with a count with an x64, and a data would be a pointer to like heaps, whatnot. It's kind of like that, right? But yeah, why would it be a dereference then? Oh, wait. I build. Sorry, it's me being silly because I copy pasted that, right? So I only changed it in one place. Sorry. Yeah. Oof. No implicit casts anymore. You see, Jai doesn't even have implicit casts, at least on the top level, right? And for now, I only detect them on the top level and only on one level of dots, so I don't even recurse into code blocks. And this is what I need to do now. So now I need to condense this code. Yeah, it works, you see? It still detects all of the 3 casts in my own program. So 21 is the first one. Line 21, yeah, this is the cast. 5, yes, this is correct one. 26, yeah, this is the correct one. And 3210, like here. Yeah, it works on my own. Yeah, code visit, right? So we go to build and we import code visit. And code visit has stuff like recurse depth first and breadth first. Code visit, yeah, get recursive nodes breadth first. Which one do we need actually? Yeah, 4 sub expressions. And do I just shift that? Well, I guess I shift that, but I don't need to. So here I am like recursing manually. Let me actually do, you know what? Let me just commit a checkpoint so I can undo if I mess shit up. Now that we have a checkpoint, we do this, and I'll just probably continue here. So I'll just like gradually move the logic from here to there. And what do we have even here? So we get an expression, sub-expression. Let me print all of them first. So print vars and format struct, and we go expr.star1 true, so it prints them really deeply. We do that. Wrong warning statement. Yeah, we don't care about that. So let me open the file. So, ooh, this is an executable. etr.jai. Let's go. So, first we have a declaration. Here, the declaration. Then we have a type instantiation. I think type instantiation is this one, right? Type in inst. In name, this is a, yeah, right? So we have line 18.5, right? Declaration 18.5, then type instantiation 18.8. This is a first statement. Then 19.5, we get another declaration. 19.11, we have unary operator, right? We have a star, so we take a pointer. This is the one. Okay, how does it do it? it goes to the left, right? Binary operator. Wait, what? Why does it return twice? Oh, so 5 and no. Why does it return two binary operators? Like what? 21.5 and 17.13? Yeah, they have different node flags. This is true. Wait, what? Allowed by context. And this one is no. That's a good point. They also have a different type. Look at that. Yeah, I'll need to inspect that. They also have different type info. And one of them like ends at column 17. So this is the entire one. And another one ends at column 13, which is yeah, here. Guys, yes, the first one is equals. The second one is this dot that stems from here to here. But why both of them are, yeah, one of them, yes, one of them is this, another one is this, because this dot is a binary operator. It's all good, it's all good. Good. Right, we got like two binary, yeah, here where it was. So we got two binary operators. So we get like this, then we get this, no, we get this entire one, then we get this small one, then we get the right side literal, then we get identifier, right? Then we get another identifier, then we get a binary operator. Wait, what? Yeah, ident, binary operator. So ident. I think this is the binary operator, no? I think it should be unary operator. Shouldn't it? 23, line 20. Oh, why is it line 23 though? I mean, true, it is a binary operator on line 23, but shouldn't it be... Huh. Oh, no. So we get identifier here. And we need to traverse into it. So yeah, we get the identifier and it will tell us about unary or something, if I recall correctly, right? So if I get to build, I get identifier and I need to get its expression and I check, yeah, okay, that's fine, yeah. So there's that. We can start here. I'll just get nodes until I get... I will get nodes if it's a binary operator. I will get a binary operator. Not even binary. I will get an identifier, which has an expression, which will be a unary dot, unary star. Basically, there's two ways I found to detect an implicit dereference. First one is check if identifier has unary dot, unary star. From a different line, very important. And second one is detect a cast. So let's try that. And I think depth first kind of works. It gets like overall operator, and then it goes like small, right side, left side. Like it kind of does this. Let's also check, oh wait, I do breadth first here. Never mind, this was breadth first. And let's check depth first. Yeah, it does that. Yeah, it does breadth because it doesn't go all the way to the left side. It actually goes all the way, goes left, right, yeah. And if we get depth first, I assume it will be like, it will be more like the declaration on the line 19. So what do we have? Declaration, right? Type instantiation, this, and then the declaration on line 20. So we have a declaration 25. Then we have so from 5 to 13. Then we have a unary operator on 2011. Okay. Then we have an identifier on 2012. So we descend into the right side. Then we have identifier on the 2012. Yeah, this one. Then we have binary operator 22.5. Oh, this one. Huh. Wait, what? I don't get it. We have a declaration, 22.5, 22. So we have the entire declaration. Then we have unary operator, and we have an identifier, 22.12. Oh, so I guess if you get a declaration, you don't get the left side. So here I didn't get even left side of a left identifier. That's a weird one. I guess you're supposed to get I guess you're supposed to get it from the instantiation itself. Let's check the line 22. That's the most important one. So we got a binary operator, the entire one. Then we got a literal. So then we get the right side. Then we get the binary operator, which is this dot 5. Yeah, this binary operator 213. Then we get identifier on the column 8. So again, the right side, we get the right side. And then we get identifier on the 5. Nice. So this is kind of, we descend and we first fully explore the right side. Then we fully explore the left side. I think I like the breadth first approach kind of more. If I go depth first, yeah, so first I will detect implicit dereference, then I will go down. So I will, if I go depth first, I will be detecting implicit dereference first, like kind of top level implicit dereference, and if there are internal ones, I will detect them later. And if I go breadth first, I will be getting implicit dereference like kind of left to right in this sort of way. I don't even know what's better. Anyway, so do we like depth first approach? It's probably fine, right? So let's try depth first and see how it gets collected, how we collect the identifiers. So if expr.kind equals identifier, ident cast code ident expr, then after we got like the identifier, we need to check whether it has a resolve declaration and expression. So how do we do that? Expression equals fx identifier dot resolved declaration, then ident resolved declaration dot expression. If this is a null pointer, this will blow up, so I guess we do that. Then we get ident solved declaration dot expression. But yeah, expr, right? If expr and expr kind unary operator. We get the unary operator. Op equals to cast code unary operator expr. And if UO operator type, right? So unary operator handles a type, and type is an actual like string for an operator, or rather like a number that represents a certain kind of type, right? So here's a char star. So this is like an implicit unary operator, and I guess we can also check and like UO dot location dot L0 is less than, so it's like previous than like ident dot location dot L0. So and what I mean by that is implicit dereference on the identifier is well, how do I write it without tautology? Is signaled by it having a unary star that actually goes over from somewhere above in the code where the pointer is, I don't know, like declared, when the pointer is declared, right? For example, so for example, we have A equals some struct, right? PA equals pointer to A. Here's actual unary star. and then we have b some other struct that holds some struct, or like first struct, some other struct that holds first struct, like other struct that holds first struct, and b that a equals ba, or no, how do you it's not like that. No, it's not like this. So the example would be, so we have a first struct, we have the second struct that holds, and then we have pointer b equals point to b, right? And then we do pb that a equals a, right? Here pb is implicitly dereferenced, and it's signaled by its identifier actual unary star is here. Here pb is implicitly dereferenced, and its identifier carries the star from the previous line. So does this explanation make sense to you, like to random people in the chat? It's like why I'm comparing lines. That's why we're checking that the star comes from some previous line. Maybe we don't really need this check, but want to be sure. Like maybe I'll remove it. For you it makes sense. I mean, that's cool. So yeah, if we have that, right, then we just say that, okay, we detected implicit dereference. Let me have probably an array, like dynamic array, derefs, like implicit derefs is gonna be a dynamic array of what, code node pointers maybe, right? Do we all we need is a ident enclosed load. So we need enclosed load. Oh, enclosed load is on an identifier. Yeah, it isn't. It is code node. So I start my English.exe is not responding. Code node. So on here I can array add it, right? So array add implicit derefs and ident. And like type checked all we can just do what? For implicit derefs, we can just print if implicit derefs that count more than 0, we can do print detected implicit dereferences. Implicit derefs that count, and then for implicit derefs we'll be printing like this. We'll do file it enclosed load, and then we'll do file fully path file name, it location L0, it location C, like that. And I guess we can indent them a little bit. So if we run now, what's gonna happen? We are just failed to compile. Identifier expert is used here, but shadowed later in the same block. Oh, if expert kind. Oh, fucking fuck, look at this. So sub expression and expr equals to, boom, I declared identifier sub expr. Yeah, it's up. Cool. You have detect 7 implicit dereferences. Ooh, no, that's not good. It can't be 7. What? ptr.jai. So it says 22. 22.5. Okay, this is correct. But why does it do 23.5? Oh, wait, no? But we have explicit dereference here. No, so now we get false positives, right? So yeah, this one is dereferenced. This is true, it is dereferenced. But it's dereferenced explicitly. I get dereference in here, this is true. But it's explicit, but we detect it as implicit, that's bad. And then 27, 27.16. Huh, it gets detected, but it should be detected through a cast. Like this should be an implicit cast. Then 29.16. Again, this is an explicit one. This is also an explicit one. 30. Yeah. And then 33. Yeah, PT. So it detects dereferences, but it also has a false positive for explicit ones. So this is bad. So we need to get an identifier. So it gives me a unary operator regardless. Let me print vars on this bitch. Like that. And let's check the ones that have line 23. Yeah. So line 23. We have an identifier. 23.5 here, ident on 23.5. Other one's 23.7. What? 23.5. 23.10. Okay, so we need to get, so we need to like, so we need to write it out. If it's depth first, it means that we get an operator somewhere here. No? Oh, I only print identifiers, so... Oh, wow. I commented out wrong line. Line 23, yeah. So we get binary operator, literal, and another binary operator. And I think I need to check that this binary operator is an explicit dereference. And after that, maybe I will like don't do that. Oh wait, there is a unary operator, but it has the same line. What the fuck? No, that's bullshit. Wait a second. Wait a minute. No. Yes, it has this is correct one. It has a unary operator, the correct unary operator, but I'm kind of going deeper. Oh, you know what? I think this identifier always carries a unary dot. It literally always carries the implicit, it literally always carries this dereference, even if we explicitly dereference it. I think that's what happens. So we had 23 dot, where is it? 23.7. Yeah, we have a unary operator, and before that we get identifier on 10. So yeah, we have the right side. If it is a binary operator, let me actually test it out. Like what it even is. Binary operator. So if subexpression kind identifier, else if sub expr that kind equals to binary operator. Let me just record those operators. So like what do we even have? Op equals to cast code binary operator sub expr, and then let's print vars, that motherfucker. Format struct op.star, 1 true. Yeah. So, and let's search for line 23. So this one is line 22. 61 is dot on line 22. So this is this one, right? Yeah, 22, 5. Whoa, whoa, whoa. Ah, yeah, this entire dot is 20, yeah, 61, okay. Line 23, let's search for line 23. Okay, line 23, and we have also 61. So 23, 7. So we get this dot on line 23, 7, binary operator. And we also get this one on 46. 46 is that, and 61 is equals. Oh, 61 is equals, my bad. So we have 46, which is a dot. 46 is a dot, binary operator. So this is an equals on line on 7. Here we have, yeah, here we have a dot. Unary operator. Where's another binary operator? Oh, that's it. Oh, shit. Wait, but this unary operator comes from the same line. No, that's incorrect. No, that's fine. That's fine, but so how do I prevent that from happening? I have a binary operator which is a dot, and then I have a unary operator which is a star. That's from 7 to 9, and binary operator is from 7 to 15. How do I combine them together? So I need to do it so that I don't detect those. And after, so this is the right part. I see. So I get this unary dot, and only then I get the identifier. Okay. I think I get it. I think I get it. Right. So I get this dot, and even on top of that, so I get this operator from 7 to 19. This is the equals. Operator type 61 is the equal sign. So I get this one. Then I descend down, literal another binary operator. So from 7 to 15. So from this, so I get this dot. I wonder why I never get this one. But yeah, anyway, I get this dot. Which is, yeah, 46. Okay. I recurse down, I get identifier from 10 to 15. Right, so I get the right side of this dot. Then I get some unary operator, and then I get the left identifier from 5 to 7. Let's also dereference unary operator and see what it is. Else if sub expr.kind equals unary operator. Code, and this would be like 169 or something like that. And we get unary operation line 20, no, not line 20, line 23. We're looking for line 23. Unary, yeah, here is, yeah, okay, here it is. So 169 is dot star. Here we go. 23.7, 23.9. But why do we get both? We get binary operator 23.7. So we get a dot, and then we get dot star for the same one. So yeah. So what I need to do is I need to get this unary operator. And if I get this unary operator, this means that the next operator, the next one on the left, will actually be explicitly dereferenced, right? It's like if you get unary, you say skip next. And if next identifier, we skip next. But I mean, it might not be identifier. It might be literally anything else. But yeah, now I want to check if I can do this. Also, let me see if I want to try breadth first again and see if maybe this one gives me better result. Breadth. Yeah. So where do we get this unary operator? Line 11? What? Ah, line 20. Okay. Let's see line 23. First, we need to check, we need to get, yeah, we get the same results, exactly same results. And we scroll up and we get line 23. How do we get them? We get binary operator equals. Then we get binary operator dot. So equals, dot, then right side literal. Then we get unary. Oh, that's kind of cool. So we get the unary operator, binary unary. After binary, we get the right side identifier, and then we get left side identifier. I'm too cooked for this. Yeah, so breath first, breath first, won't let me say skip next. Where do you have unary? Yeah, unary 169, yeah. So if I get this, I want to say just skip the next skip next left side identifier. That's kind of what I want to tell it. Oh, you know, we have a sub expression. Is this the same sub expression? Wait, so sub expression is 741b0. No, it's something completely different. Wait, do we have something? Do we have it somewhere? Oh, it's no, only one. I wonder what's that. Wait, what the fuck is a sub expression on sub expression is some kind of a code note. What's that? Okay, let me get sub expression. Op sub equals to op dot sub expression, and let's print is not a member. Oh, it's just sub expression. Right, so what do we have here? Some kind of identifier. Wait, line 20. Unary. Yeah, here we go. On line 23, the sub-expression is something identifier with 23. Oh, so that's it. We just need to skip, but why does it have a different address? Wait, I don't know its address. I literally, so op sub, let me just print this. And when I print identifiers, where do I print them? Print vars. Oh yeah, ident. Yeah, I want to print vars. Ident. There you go. So op sub is kind identifier. Wait, do I? How do I? Oh, does it get dereferenced automatically? Oh, I didn't know that. Let me just print it without dereferencing. Without, I mean, yeah. Op sub and yeah, it's like that. So op sub. Yeah, okay. So we get sub node with this address. And where do we get ident with the same address? So for is, yeah, that's the one. Okay. Look at this. So if we get Unary operator of 169, we need to skip its sub-expression. Yes. Fucking got him. So if op dot operator type equals that operator type 169, it's called postfix dereference. Then yeah, I found the way how to skip false positive implicit dereference. I know that you don't care anymore. All you care about is fucking telnet chess, but if I knew that I would be programming telnet today, I would get a lot of stonks. If it's postfix dereference, so identifier to skip equals to well, op that sub expression, right? It's like node to skip. Yeah, node to skip. And let me do something like node to skip is gonna be a pointer to code node, right? And I guess we have a sub-expressions here, right? And if sub-exper equals to node to skip, then we do node to skip equals null, and we just continue. Will that help? Will it work? Unary.dereference only match enum types, but here's trying to... Unary.dereferences only match to enum types. Oh fuck, because it's a loose enum, so it's unary code unary operator dot operator operate. Oh, it's just operator type. Okay, so it's just like, bro, operator type. Yeah, there you go. No mismatch type. Fuck you. It's XX. XX this bitch. Oh, it works. Does it work? We reduce something. 22. Okay, 22 is correct. Now 27, correct. 33, correct. And 34 shouldn't be detected. Yeah, 24 shouldn't be detected. So we're literally almost there. But why is this one getting detected? Why is this one getting detected? 22, correct. 27, correct. Oh, it has a unary stuff, but it doesn't have an explicit postfix. But this should be fine, I mean, because, right? Because this shit, this motherfucker accepts a pointer. But yeah, that's a completely different code path where we check for casts. This is also incorrect. It's like technically incorrect. I mean, no, it works fine. It detects unary, like this unary dot. Huh. What if we do test a PTR, right? And it's gonna be a pointer to A. And if I do like this, like this should be fine. Do we detect it? 29. Yes, we detected. This is another false positive. Yeah, we should check if it's a right side, we should check for casts, for implicit cast. If binary operator. So what's that? Yeah, this we need to, we can safely skip this. Let me remove the print. Let me remove this. Wait, not. So I need to port this code path. If op if kind is cast. So if we have an identifier, we kind of recursed here, but first we need to check for casts. Yeah. And then else if. Yeah. So first, if, wait. Not here. If sub expression is identity, so if sub exper dot kind equals cast, and then else if, and then we'll literally just copy paste what we did like that. Yeah, boy. Cast equals code cast. It's like sub exper. If cast flags equals this, then we just literally array add this implicit derefs and cast. That's it, right? Oh, why does it detect 28? It detects it twice. So 28, this is correct. Oh, it still detects 29. Fuck. But now it detects 35 and it's still, wait. And why does it detect 26, 28 twice? So 16? Why does it do this twice though? Oh, because, yeah, because it kind of checks both. It gets the cast, and then I need to skip that. Let me actually print this cast, but without format struct. So I get this address and I can skip it. And yeah, I still print an identifier. So we get a cast. Look at this. Why is it? Huh? Why is it formatted? Wait, what? Where do I? Ah, shit. Because I'm printing a sub expression. Right. Let me go cast. Yeah. So we have a code cast with this address, and I assume we should be getting the identifier with the same address. No? Ah, no, we actually don't. So maybe the identifier is one of cast's children. Yeah, like an expression or something. Let's check cast dot expression. This one, FC50. Yes, look at this. Here's the identifier. Yeah. So if we do that, we array add and we do node to skip equals like clearly this. And oh, how am I stupid? It's literally expression. What do you not like? Ah, it doesn't like my typos. Duh. Okay. No. I mean, we deduplicated, but it still detects stuff. We have 35, 36, so this is a... I thought we skipped. Huh. That's a weird one. Why would we... So we add a cast, and after that we actually need to really skip the identifier. Let's print the sub-expression again to print vars. Yeah, cast dot one true, and then I also want to do cast dot expression. Right, so we get cast, we get the expression for an identifier. 2816. 2816. How do we skip 36? So, okay, I get this 29. The way we remove it is by checking if it's like the right side of, if like left side of an assignment is a pointer. So I get how we check that. This is an easy one. I can just clean it up later. But why does it triggers on line 36? Because this should get skipped. So I get the cast, get this. Let me print an identifier. Like that. Print. So we print ident and we print the ident dereferenced. If blah 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 x per unary operator. Yeah, and I actually want to print it here. So if we go to this path, right? So I get cast. So line 23. Okay, line 28, line 29. No, line 36 here. Oh, because it's not a cast. My logic actually works correctly. So yeah. Okay. I only have false positives when I don't have like. Yeah, so the way I do it here, this works, right? But it's way too greedy. It's way too greedy. Yeah, it's kind of greedy. It's greedy as fuck. And the way I kind of avoid it is, so if I get like a sub expression, so line 29, for example, line 29 is, yeah, this is a false positive, right? If I print it, let's scroll to line 29, right? Yeah, so I have a binary operator which is equals on line 29. Then I have this like right side. This is the right side. This is the one I'm detecting, by the way. So it's 29, 20. Yeah, this is the one I'm detecting, and I need to skip it. And the way I skip it is, so we get here, and I need to check that previous one is a binary operator of equals. Then I know that my identifier is on the right side, right? Then I can sort of check that my left side. Oh, and then I need to recurse like all the way to see that this is just a pointer. Yeah, I mean I see exactly how to do it. It's just kind of involved. Yeah, so this is what I'm gonna do. I'm going to only check for Unary, for this Unary operator when I am on the right side of a dot. Well, first I need to resurrect this part, like else if sub expert.kind equals binary operator, right? Code binary operator. Code binary. It has right side. Yeah, right side. It's not like node to if this equals to char dot, right? If operator is a dot, then we need to check equals operator dot right. And if right is an identifier, then we check it. So when we go here, kind is identifier and sub expr equals to need to check, node to check. Then and only then we do that. And node to check is a code node. Oh, now we're okay. Now we only so it gets this one, it checks it after dot, that's fine. Why doesn't it check this one though? Line 23, binary operator, it is a dot. Yeah, 61 is a dot. Oh, 46 is a dot. What's 61? Equals. Okay, this is an equals. Fine. We descend further. Here's 46 is a dot. Yeah. 23.5. 23.5, yeah. So it starts here with a dot. We have 61, which is an operator equals. I'm printing too egregious, I think. No, sub-expr. No, okay, not quite too egregious. So 23.517. 23.5, yeah, that's the one. Then we get another one. Then we get this dot. I'm surprised that we go to the left first. But yeah, whatever. We get literal. Cool. Then we go to an identifier. Yeah, two identifiers. One on the left, one on the right. Huh. So right is this, left is this. I wonder why don't we catch them? If an identifier. Where do I print ident? I'm not even printing the idents. Let me remove that first and see. 23, 46. Yeah, 46, okay. Literal ident. So EB00 PA. PA. Where's A int? Oh shit, we don't get it, do we? So we get this one, which is the left one. Why do we literally skip it though? I'm surprised that we skip the right one, like completely. Oh wait, no, it is dot. A int. Oh, A int is a, okay. Yeah, the pointer that gets dereferenced is PA. Not right. I need to skip the left side. Yes, sorry. This is like, I mean, this is me just getting tired at this point. It's like been 5 hours, yeah. So I need to, well, first get that, and I need to check not the right side, but the left one, because the left is the one getting dereferenced. Right, and when I do that, I get 23, 28. Okay, we're close. This one on 23 gets correctly noticed, and this one on 28 as well. And I need to get back my 35 to 36. And the way I get it is by checking whether we are in a procedure call. But I think this should be fine, because this should technically be a cast. Is it not? So let's check. Line 35, procedure call. Oh, if it's a procedure call, I need to descend into the arguments. Cool. So I actually implemented that already when I experimented. Not procedure call, fuck, build. Here, if we are a procedure call, right? So it's here, yeah. So if we are a procedure call, so if cast, if identifier and check, binary operator, unary operator, and a procedure call, here. Let me indent it properly. We cast, not statement, it's gonna be sub-expr, and if sub-expr kind is a procedure call, we cast the procedure call, we get the arguments, and we iterate over the arguments sorted. And if kind is cast of an argument, and we get the cast, then we just array add implicit dereferences and cast. And now we call, and yeah, this is what I was talking about. We get everything in our reports, 23, 28, 35, 35, and so line 23, we dereference PA implicitly and assign to A int something. This detects. 24 is fine because we explicitly dereference PA, right, and assign stuff, so we don't detect it. Now we initialize a bunch of stuff, and on line 28 we have test A being implicitly dereferenced because we assign a pointer to it. And if I add that and do this, this should be fine, right? Yes, you see, so this is an implicit dereference of PA pointer. We dereference it and assign to test A, and we detect it. Here we go. Column 16 is this one. Yeah, literally on the identifier. This is an explicit dereference, so we should be fine. Yeah. Next one is I assign pointer to pointer on a struct. We detect that it's fine, totally not an implicit dereference. These two are both explicit, right? We have test B, which is an integer, and I actually dereference PA and get a int, which is fine. Explicit dereference should be, yeah, okay, we get, I wonder if we detect, I don't tested it, but what if we do test B and we do PA that a int? So here PA gets implicitly dereferenced, right? So this should be detected. Will it though? On line 33. Hey, look at that! A test that I didn't have coded manually, just via a virtue of code visit and some cool logic. We literally detected that on the line 33 we implicitly dereference in PA. Yeah, on column 16, cool. This is skipped because we dereference it explicitly. And then line 37, yeah, gets detected because we implicitly dereferenced PT because test procedure accepts a struct, not a pointer. So here it gets like dereferenced. I mean, I still wonder if it actually what happens because, you know, in Jai structs get passed maybe by reference. So maybe, I mean, maybe that, like the language says that this is an implicit cast dereference. So we just trust it. And this is fine because test2 accepts pointer and we pass a pointer. Yeah, this is great. Oh, that's literally it. So, and let me clean up the build script a little bit. So after the continue, I can remove all of that. Boom. And I mean, minus the debug prints. Right, let me just comment out. Right, let me just comment stuff out. Ooh, these are commented out. This I don't need at all. Yeah, and there you go. Yeah, I compile the stuff, and I get 4 implicit dereference detected. And if I remove main, I should get a lot more if I don't crash anywhere. Yeah. So basic print. So it only detects implicit dereference in the code I'm using. Let's actually check if basic print indeed dereference stuff or it's another like false positive. So basic print.jai 792gg print array, it passes a builder. What is 48 format? So format is actually a pointer to a format array. And what print array accepts? 1, 2, 3 format. Oh, and it accepts format array not as a pointer. Look at that. I mean, it is a struct, but we pass a pointer to a struct that gets implicitly dereferenced. Hey, this is legit. This is legit dereference. Nice. 755. Check null for matter. What do you pass? 41. So this one, format, again. Yeah, cast to a pointer to format struct. Yeah, so check null for matter accepts, yeah, for matter, and it gets implicitly dereferenced. Look at that. Again, I'm not sure how valid implicit dereference in case when we pass a struct, you know, because of maybe by reference, but I mean, the compiler tells us that it is an implicit implicit dereference, so we just trust it. Maybe it makes sense to exclude procedure calls because they're kind of special, but we'll see. 780. Yeah, I guess it does the format, which is a pointer to the struct, and 779. Wait, what? 779. Ah, yeah, check null formatter. Yes, okay. Yeah, I mean, these all of these are dereferences. That's great. I mean, we're fucking balling. Overall, it's great. Apart from like deeply nested dots, it all works. I'm pretty happy with the result. Another metaprogram in W. I yapped a lot, probably out of 5.5 hours, and I think I worked for like 3. Maybe I will make a YouTube video out of it. We'll see how it goes. Anyway, let's maybe find someone to raid. Here's my shill link. Like, follow me if you want. Discord is where I post notifications when I go live. And yeah.